Have you ever wondered what the future holds for our planet? From the climate changes already unfolding today, to the slow drift of continents, the disappearance of life, the death of the sun, and the distant future of the universe itself. Join me on an epic journey through billions of years of time as we witness the incredible story of Earth's final chapters, guided by science and brought to life through time-lapse. Our planet has survived asteroid impacts, ice ages, and mass extinctions over its 4.5 billion year history. Yet the greatest chapter of its story has not been written by the past, but by the future. That future has already begun. Long before distant cosmic events reshape the solar system, the first changes are unfolding today. Every year, greenhouse gases released into the atmosphere trap a little more of the sun's heat. Instead of escaping into space as infrared radiation, part of that energy remains on Earth, gradually warming the air, the oceans, and the great ice sheets that have covered the poles for thousands of years. As the planet warms, the oceans respond first. Water expands as it absorbs heat, causing sea levels to rise even before large amounts of ice have melted. At the same time, glaciers and polar ice sheets slowly release more water into the seas, adding to the rising tides. As bright white ice disappears, darker ocean water and exposed land absorb even more sunlight, accelerating the warming in a powerful feedback loop. Human civilization begins adapting to these changes. Coastal cities build higher seawalls, reinforce roads and harbors, and redesign waterfronts to defend themselves against an increasingly unpredictable ocean. Some communities succeed in adapting, while others are eventually forced to abandon places that have become too vulnerable to flooding and stronger coastal storms. By the end of this century, the future is not yet fixed. The choices humanity makes today will determine how severe the warming becomes during the centuries ahead. Yet even if greenhouse gas emissions are greatly reduced, the oceans continue storing enormous amounts of heat. Their immense size gives them a kind of memory, allowing warming and sea level rise to continue long after emissions begin to fall. Carbon dioxide itself remains in Earth's climate system for centuries, and in some forms, even thousands of years. Because of this, coastlines continue to shift as rising seas and stronger storms reshape the boundaries between land and ocean. What were once thriving coastal cities gradually become archaeological sites, while new coastlines emerge elsewhere. As centuries turn into millennia, the evidence of our civilization slowly becomes part of the planet itself. Towers collapse, roads crack, bridges rust, and abandoned buildings are worn away by rain, wind, ice, and time. Metals oxidize, plastics break into microscopic fragments, and concrete crumbles into sediment. Eventually, the civilization that once dominated the planet survives only as a thin geological layer buried within Earth's rocks, a lasting signature of the age scientists call the Anthropocene. But while humanity's traces slowly disappear, the planet continues following much older rhythms that have shaped it for millions of years. Earth's orbit still changes in slow, predictable cycles. These subtle variations in the planet's motion around the sun have repeatedly triggered ice ages throughout geological history. Under natural conditions, another glacial period would eventually arrive. However, the vast amount of carbon released by human activity may delay that next ice age for tens of thousands of years, altering a cycle that has governed Earth's climate long before civilization ever existed. Meanwhile, rivers continue carving valleys through landscapes that humanity once inhabited. Mountains rise as tectonic forces push continents together, only to be slowly worn back down by erosion. Evolution never stops, and species continue adapting to the changing world just as life has done for billions of years. Far beneath the surface, another transformation is already underway. Deep within East Africa, the Earth's crust is slowly stretching apart. Gigantic fractures widen year after year, while magma rises from below, weakening the crust even further. Although the movement is almost impossible to notice within a human lifetime, over millions of years the widening rift eventually reaches the sea. Ocean water begins flooding into the newly opened basin, creating the birth of an entirely new ocean. A continent that once seemed permanent quietly begins breaking apart, reminding us that even the shape of the Earth itself is only temporary. And this is only the beginning of a story that will unfold over hundreds of millions and eventually billions of years. But while Earth continues regulating itself, another force beyond the planet grows steadily stronger. The sun, although remarkably stable on human timescales, is slowly changing. Every second, deep within its core, hydrogen atoms fuse together to form helium, releasing the energy that has illuminated the solar system for billions of years. As this process continues, the sun's core gradually becomes denser and hotter, causing the star to shine just a little brighter with each passing million years. At first, the increase is almost impossible to notice, but over immense stretches of time, that additional sunlight begins altering Earth's climate in profound ways. Warmer temperatures accelerate evaporation across the oceans, sending greater amounts of water vapor into the atmosphere. Because water vapor is itself a powerful greenhouse gas, it traps even more heat, reinforcing the warming already underway. Clouds and oceans continue buffering much of this extra energy, delaying the most dramatic changes. Yet these natural systems cannot compensate forever. Gradually, the balance that has allowed complex life to flourish for hundreds of millions of years begins to shift. Plants, the foundation of nearly every ecosystem on Earth, face an unexpected challenge. Although they depend on sunlight to survive, they also require carbon dioxide to build their tissues through photosynthesis. Over millions of years, weathering continues removing carbon dioxide from the atmosphere faster than volcanoes can replace it. As atmospheric carbon dioxide slowly declines, photosynthesis becomes increasingly difficult. Some plant species disappear first, unable to survive under the new conditions. Others endure a little longer, adapting where they can. Yet even the most resilient lineages cannot escape the changing chemistry forever. The great forests that once covered continents begin shrinking. Dense jungles give way to scattered woodlands, which slowly fade into isolated pockets of vegetation. Vast regions of the supercontinent become dry, barren landscapes where only the hardiest organisms can survive. Without forests anchoring the soil and sustaining the climate, Earth's ecosystems begin entering a slow but irreversible decline. The age of abundant life is approaching its final chapter. As millions of years pass, Earth becomes increasingly unfamiliar. The planet is still alive, its continents still drifting, its volcanoes still erupting, and its oceans still moving with the tides. Yet the delicate balance that once sustained complex life is slowly unraveling. The forests that once covered much of the land begin to retreat. Over immense stretches of time, weathering removes more carbon dioxide from the atmosphere than volcanoes can replace. As carbon dioxide levels continue to fall, photosynthesis becomes increasingly difficult, and the world's great forests gradually disappear. Without abundant plant life, the foundations of Earth's ecosystems begin to collapse. Herbivores lose their primary food source, predators soon follow, and food webs that took hundreds of millions of years to evolve slowly unravel. Large animals disappear first, unable to meet their enormous energy demands, while smaller and more adaptable species survive a little longer. Eventually, even they begin to vanish as the planet grows hotter and drier. Meanwhile, the sun continues its slow evolution. With every passing million years, it shines slightly brighter, sending more energy toward Earth. Higher temperatures accelerate evaporation, filling the atmosphere with more water vapor, a powerful greenhouse gas that traps even more heat. Although scientists continue refining the exact timeline, they agree on the overall direction. Earth is becoming steadily warmer, and the conditions required for complex life are disappearing. As the remaining forests fade away, oxygen production also begins to decline. The rich atmosphere that once supported billions of animals slowly changes, making survival increasingly difficult. The vibrant biosphere that covered the planet for hundreds of millions of years gives way to a much simpler world. Yet, life refuses to disappear without a final struggle. Microorganisms continue surviving in places where larger organisms cannot, deep underground, beneath the ocean floor, and around hydrothermal vents hidden beneath the sea. These microscopic forms of life inherit a planet that was once filled with forests, oceans, and civilizations. But even their time is limited. As the sun grows brighter still, Earth's oceans begin evaporating faster than they can be replenished. Coastlines retreat, shallow seas become vast salt flats, and rivers that once carved continents run dry. High in the atmosphere, sunlight breaks apart water molecules, allowing hydrogen to escape permanently into space. With every escaping atom, Earth loses a tiny fraction of its water forever. Over millions of years, the oceans shrink into isolated basins before disappearing completely. The blue planet gradually becomes a dry, barren world. Surface temperatures climb beyond the point where liquid water can remain stable, and the atmosphere transforms into an intense greenhouse environment. The last underground reservoirs dry up. The final microbial refuges disappear. At last, after nearly 4 billion years of uninterrupted life, the final living organism dies. For the first time in Earth's history, the planet falls completely silent. Yet, even though life has come to an end, Earth's story is far from over. Far above the lifeless world, the sun continues its own slow transformation, preparing the next and perhaps most dramatic chapter in the history of the solar system. Billions of years pass in silence. Earth is now a scorched and lifeless world, orbiting a star that is approaching the end of its life. Deep within the sun, the hydrogen fuel that has powered it for nearly 10 billion years is finally exhausted. Without enough hydrogen to sustain fusion in its core, gravity begins compressing the sun's center, making it hotter and denser. Fusion continues in a surrounding shell, producing even more energy and causing the sun to expand dramatically. Over millions of years, it transforms into a red giant, growing hundreds of times larger than it is today. The inner solar system is changed forever. Mercury is the first planet to disappear, consumed by the sun's expanding atmosphere. Venus soon follows, its surface melting long before the planet itself is engulfed. Earth's fate, however, remains uncertain. As the sun expands, it also loses a significant amount of its mass through powerful stellar winds. With less mass, its gravitational pull weakens, allowing Earth's orbit to drift slowly outward. At the same time, tidal forces generated by the sun's enormous outer atmosphere may pull the planet inward. Whether Earth escapes or is ultimately swallowed depends on the balance between these competing effects. And scientists continue to study which outcome is more likely. If the sun's gravity prevails, Earth spirals into the giant star. Its crust melts, its mantle vaporizes, and eventually the entire planet dissolves within the sun's outer layers. After more than 4.5 billion years, Earth finally ceases to exist. If Earth manages to avoid being engulfed, its survival is only symbolic. The oceans are long gone, the atmosphere has vanished, and the surface has been sterilized by unimaginable heat. What remains is a dark, lifeless world orbiting an aging star. Either way, the living planet is gone forever. The sun's evolution continues. For a relatively brief period, helium fusion ignites within its core, providing one final source of energy before the remaining nuclear fuel is exhausted. The star then expands once more, shedding its outer layers into space through powerful stellar winds. These glowing shells of gas form a spectacular planetary nebula that shines across the cosmos for only a few tens of thousands of years, a brief moment on the cosmic timescale. At its center remains the exposed core of the sun, a white dwarf. Roughly the size of Earth but containing nearly half the sun's original mass, it no longer produces energy through fusion. Instead, it slowly radiates away the immense heat stored during billions of years of stellar evolution. The solar system has entered its final chapter. The brilliant star that once nurtured life on Earth has become a faint stellar ember, surrounded only by scattered debris and the silent remnants of worlds that once orbited it. But even the death of the sun is not the end of the story. Beyond the fading white dwarf, the universe continues evolving, carrying the remains of our solar system into an unimaginably distant future.